In this lesson, we're going to learn about the domain and range of a function. This is the first in a two-part series on the topic, and in this lesson we're going to focus on what domain and range are and how to determine the domain and range giving a function as a mapping diagram or as a list of ordered pairs. Let's start with an example. Suppose we have a function that has the inputs 2, 3, and 5, and it has the outputs 6 and 9. The inputs and outputs are connected by a mapping diagram. We want to determine the domain and range of this function. But what exactly is domain and what is range? Well, domain is simply a list of the valid inputs or x values that the function has. If we look at our mapping diagram, we see that we have the inputs 2, 3, and 5. 2, 3, and 5 altogether make up the domain of this function. So we would say the domain is the numbers 2, 3, and 5. Range is a list of the valid outputs or y values that the function has. In this function, we have two different outputs, 6 and 9. So the range is the numbers 6 and 9. Please be careful when using the words domain and range. If we look at the numbers in the domain, 2, 3, and 5, altogether they are referred to as the domain. But individually, they are simply inputs. It would be incorrectly to say that 2 was a domain. 2 is not a domain. 2 is an input or a member of the domain. Similarly, when we look at the numbers in the range, 6 and 9, 6 and 9 together make up the range. It's the list of all of the outputs. It would be incorrect to say that 6 was a range. 6 is not a range, it is an output or a member of the range. Range refers to all of the outputs brought together collectively. Here's an exercise for you to try. Here's a function shown in a mapping diagram with the inputs 9, 15, and 21, and the outputs 7, 9, and 18. Can you list the domain and range of this function? Please pause the video here and come back when you're ready to check answers. Let's compare answers. The inputs make up the domain. We have three inputs in this function, 9, 15, and 21. So the domain is the list of numbers 9, 15, and 21. These three numbers make up the domain. They are the valid inputs or x values for this function. How about the range? We have three outputs, 7, 9, and 18. These numbers collectively make up the range. 7, 9, and 18 are the outputs or the range of the function. What if we have our function given to us as a list of ordered pairs? Well, we know that the x values are the inputs and the y values are the outputs. If we look at the x values, 5, 7, 8, and 3, those are the inputs for our function. Those four inputs make up the domain. So the domain for this function is the set 3, 5, 7, and 8. What about the range of the function? We know that the range is the list of valid outputs or y values. In this case, we have three different outputs, 3, 2, 15, and then 2 repeats. So we have three unique outputs in this function. The range is the set 2, 3, and 15. Notice that the numbers when listed in the domain or the range are written from smallest to greatest. That's customary when we're writing domain and range or any numerical set in mathematics. Here's a problem for you to try. Here's a set of ordered pairs. Can you determine the domain and range of this function? Please pause the video here and come back when you're ready to compare answers. Let's compare answers. We know that the domain is the set of inputs. We have four inputs in this function, 7, 6, 8, and 9. Those four inputs make up the domain. The domain is the set 6, 7, 8, and 9. We know that the range is the set of y values or outputs. Here we have three different outputs, 5, 14, 3, and then 5 repeats again. Those three numbers make up the range. So the range is the set 3, 5, and 14. And now you know everything you need to know in order to get started with domain and range. Be sure to check out part 2 of this series, where we'll talk about how to determine the domain and range of a function given the graph. Remember, you can learn more about functions in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.